it will also help your understanding as well. So we're talking, like I said, the evolution of DevOps. Just a minute, please. All right, so yeah. All right, so the birth of DevOps, a portmanteau of development and operations, emerged as a response to the growing challenges. Traditionally, past efficiencies, communication gaps, and slower delivery cycles. The concept of DevOps aim to bridge this divide by fostering collaboration and automation processes. Now, let me explain this in a way that we can understand. All right, so yeah, so DevOps. If you look at the word DevOps, you can pick two. It's a six-letter words, right? So I can actually split these six-letter words into two. There is Dev, there is Ops, right? So the combination of Dev and Ops actually is what makes up DevOps. Now, so what exactly? So when we say Devs and Ops, we mean development and operations. So that's what it means. Now, the concept of DevOps came about when there were a lot of challenges with software development, so many challenges. The teams were operating in isolation. There were so many communication issues. There were inefficiencies here and there. There were what you call, slower delivery to software products in the market. Now, all of these things, was what gave birth to DevOps, right? Before you have the DevOps team, they just, sorry, not DevOps team, the development team, they just they write their code. Once they write their code, to just flip their code over to the operation teams, and the operation team just go about to deploy the application. And then over time, there were issues. So what were issues? Now imagine the development team, they just write a bunch of codes and just drop it on the desk of the operation team. And the operation team pick it up and deploy it. Now there were issues. What kind of issues? They had issues with bugs, issues. There were issues with being able to, there were issues with code-related issues. And then over time, we had things like communication breakdown. The operation team is telling us that, it's saying that, oh, we're having issues with this application due to this kind of code sent to us. And the development team is telling you that, as far as we are concerned, we have done our job. We've written the best code that is expected. We've actually, in fact, we have even deployed this application manually. And as far as we are concerned, it is working. So if it is not working from your end, the problem is from your end. So back and forth over time, we had this issue. So that's why DevOps came. So what is DevOps now doing? DevOps has now come to do what? To merge the development and the operation teams together, so that there will be collaboration between the both teams, and not just only collaboration. The communication gap will be broken down, right? And then there will be faster delivery of software, faster delivery of software within the shortest life cycle. Now, let me also explain this in this way. Now, I have deployed a couple of applications right here in Income, and more often than not, I work with the developers. Now, even as I work with the developers, and sometimes even working with the developers, there are still challenges here and there. Now imagine if I wasn't even working with the developer at all. Now, what are these challenges? Now, a developer can tell you that, oh, okay, I have worked on this application, I have built this application, and he told me that he's built this application, and I said, okay, have you tested the application? Now, sometimes the developer can tell you that, oh yes, I've tested the application, whereas in the real sense, he hasn't even tested it. Do you understand? He hasn't even tested it in the real sense, or he could have tested it, but he didn't get the best of results. But because maybe he just doesn't want to stress himself, so he just drops it and tells you, I've done it, I'm done with it. And then you assume that truly he's done with it. And you, the DevOps engineer, what you want to do. You want to do what? You want to deploy the application. And when you are deploying, what you are doing basically is to automate the deployment of the application. Now you are trying to do that, and you are running into a lot of issues, right? And the developer is telling you that, and you, because you are running into issues, you know, if you are experienced enough or smart enough to be able to troubleshoot, you could have an idea of where the problem is coming from. Right now, if you have an idea where the problem is from, because I've had that kind of issue, you know, notice where the problem is coming from. Then I talk to the developer. Developer, are you sure that this application that you worked on, are you sure it's working? Are you sure you tested it? Oh, I tested it. Then when you now say, okay, since you said you have tested it, can you now come? Can we now hop on a call so that you show me how you tested it? So let me see. And the developer starts running away, starts giving excuses here and there, here and there, here and there. From then you begin to get an idea of where the problem is, right? Because the developer knows that he hasn't really tested the application, right? Or maybe he tested it and he came across one or two things, errors that, or one or two things that he wasn't comfortable with, or he could not resolve what those issues were. So, but he would just tell you, say that he has done it. Now, imagine if there were no collaboration between us. Imagine if there were no communication between myself and maybe the developer. Do you know that in that case, the developer will just dump it and go away and say he's done with his job? And now the DevOps person or the operation team is not trying to deploy the application and is facing challenges. Now, when he's facing those challenges, he may not even know the way out of those challenges, especially if it is not something he could resolve. He will not be able to resolve them. And since he's not able to resolve them, do you know what that does? What that happens is that it takes longer time, right, for the application to be delivered, which is what we're saying by slower delivery cycles. So it takes a lot of time before what? Before you have your applications delivered. And to a large extent, that now impacts on the organization's business as a whole in the marketplace. Customers will begin to look for alternative because why? They cannot afford to, trust the organization to be able to deliver. So now this is how it works. So that's exactly what DevOps that came to do. Foster this collaboration, bridge the communication gap, right? And then all of those inefficiencies, all of those things of working in silos, which is working on your own in isolation. It has now come because most times, like I said, I will have to, first and foremost, if I have an application to deploy, first and foremost, especially if it's within an organization like this, I want to know who the developer that worked on the application is. So I reach out to the developer and I say, okay, developer, first and foremost, walk me through this application. Can I know what this application is doing? So after he's told me what the application does, and he will walk me through, or in some cases, give me a documentation, right? I'll look at the documentation on how he was able to manually deploy that application. Then I see it and I say, okay, fine, then I can now go ahead. So while I am doing my own automation of deployment, I am still in constant communication with the developer, right? So with that bridges that communication gap. That ensures that applications are delivered as fast as possible. So that's now key milestones in DevOps. So these are the milestones, these are the things that shape up the entire DevOps culture, right? The agile movement, continuous integration, continuous deployment, infrastructure as code, DevSecOps, microservices, containerization. So we're going to talk about them. Now, the agile development, which says DevOps shares its roots with the agile movement, which introduced iterative development and collaboration among cross-functional teams. Agile sets the stage for DevOps by emphasizing rapid cycles. What we are saying, DevOps took its roots from the agile movement, and agile development is a development that constantly focuses on iterative development. And that iterative development, what it means in essence is that now a project is broken down, right? A project is broken down chunks of let's say just broken down into chunks. Right, you have a project that should be done. Now the project is broken down into chunks, and once that project is broken down into chunks, which you build your design, your plan, and then your customer feedback, your monitoring of the application. Now this is how the project is broken down. Now that's the concept of agile movement. Breaks down this your project into sprints, breaks down your project into what? Into chunks, right? And the entire team now works on that project. Now, once the entire team is working on that project in that broken down form, do you know what that does? That fosters collaboration among what? Among the entire team as a whole. Do you understand? Now that does what? Like I said, that fosters collaboration among the entire team, and that helps to be able to push the entire DevOps culture, right? It helps to push the entire DevOps culture, which revolves around, which revolves around what? Around automation, continuous integration and deployment, collaboration, communication, right? And faster delivery of software products, right? So now what it does is that iterative development, which emphasizes on breaking down this particular products or this particular project into sprints, breaking them down into then so the entire team works on it collaboratively. And with that, you have a faster delivery of what? Of your software product. So now that's the entire concept of agile development. And that's the form. Now we move to now what about some of my now continuous integration. Continuous integration was pivotal in the DevOps journey. It involves developers frequently merging code into a shared repository, automatically triggering builds and tests. Continuous integration reduced integration issues and allowed for quicker identification and resolution of bugs. Yeah, I think in yesterday's case, the facilitator that took yesterday's case talked extensively about the concept of merging of your code into a shared repository. I mean, when he talked about sharing, merging your code into a particular central repository, that's when he was talking about. Right. So now the idea of continuous integration is what? Developers are frequently merging their code into what? A shared repository, which automatically does what? Trigger builds and tests. Now the developer that is working on the developer that worked on a particular software, for instance, now has a repository from which he's working from, right? Now I want to do what? I want to automate the deployment of that same software or that same application. Now, there's this particular repository, right? Now that we're all working from. So the entire concept of continuous integration is that, the developers are frequently doing what? Merging their code. They are frequently making changes. What do we mean by that? For instance, in the application that you have, let's take a WhatsApp as example. Now, let's assume that we're working on WhatsApp now. Now there's this idea that okay, now we need to introduce. I would say before now there was no concept of having you to check, right? There was nothing of such on WhatsApp. There was nothing about being able to have something like be able to put pictures on your status, being able to put videos on your status. Now all these things were features that came along the way, right? Now what happens is that now you have a whole lot of developers that are working on this particular WhatsApp project, right? Now somebody writes a code, right? Somebody writes a code because he wants to ensure that the entire goal of that code is to build that feature into that software, and the feature is for you to be able to see your status right on your WhatsApp. You can just flip and have a portion for status, right? And somebody else decides to maybe based on whatever it is that was discussed or whatever it is that was agreed, and somebody else now chooses to I need to put in another feature. Let's say a feature. Let's assume I want to put in a feature, a WhatsApp that will allow me to be able to post videos on my status, right? Now these are all features. So at the end of the day, there is a single repository, right, which everybody is working from. So what happens is that continuous integration encourages the idea of what? Merging your code. So you are continuously merging your code into that same repository, right? You continuously merge your code into that repository. It triggers your build and your test. It triggers your build and test. Test the application. It's fine. Once it goes through the test and it's fine. It deploys to production. Right. So that is what happens. So that's what the idea of continuous integration. We cannot say because we want to introduce. I mean, over time now, most times what you do is that you get what's it called? You get maybe a notification that a certain application that you are using is due for update. Now, what you think is happening in that update? That update is very simple. Now, when the application updates, a lot of new features has been included. That's the reason why sometimes, if you are using, for instance, you are using Twitter, and you have updated your let's say you've even updated your application, right? And if new changes have been introduced, right, into that app, you are not going to have access to them until you do it, until you update the application. That's when you have access to them, right? So now the concept of continuous integration is that, okay, we want to impute new changes into this application. We're not going to shut down. We're not going to shut down the application because we want to impute changes into it, right? We're going to be imputing the changes while the application is still functional and running, right? So that's the concept of continuous integration. Developers are frequently merging their code into a shared repository. Now, another milestone that DevOps has actually brought is what you call infrastructure as code. Now, infrastructure as code, I introduced the practice of managing infrastructure through code, enabling the automation of provisioning and configuration tasks. This concept revolutionized infrastructure management and made it more consistent and reliable. Now, this, in a very simple way, is that what infrastructure as code has come to do, which is one of the milestones of DevOps, is that you can build your infrastructure, right, with just a bunch of codes. When we say you are building your infrastructure, what exactly do we mean? We're talking about your servers, for instance, your database, for instance, right? Your servers, your database, your storage. You are building all of these things with just a bunch of codes. As against, for instance, now, if I want to, if I want to set up a server on AWS, right? I will do what? I'll go to the console. When I get to the console, I'll go to instance. I get to instance, click on launching instance, then I begin to fill up where I need to fill up that will make up for building up or spinning up of my server, like giving it a name, generating the private key pair, setting up the security group, all of these things. All of these things are the things I'm going to do, right, on the user interface, right, to be able to set up a server, right? So if I want to set up an RDS as well, right, that's your relational database, I'm going to go through this process, right, of going to the UI, web UI. I'm sure you know what I mean by web UI. That's the user interface. You go there and begin to click here before you can set it up. Now, if I want to do the same thing with S3, which is a storage service, I would go through the same process, right? Now, but infrastructure as code is not like, oh, okay, no, rather than going through all of this process, I could just write a bunch of codes that at the click of the button, it will spin up all this infrastructure for me at the same time, right? It's not going to be a case of I'll come and set up the server first, I'll go back again, go to database, and go and set up database again, then I'm done, and I'll go to S3, go and set up S3. No, a bunch of codes, and at the click of a button, right, everything is spinned up immediately. Now what that has done is that, number one, that has reduced the time you spend on trying to do what? On trying to set up, your infrastructure. That's one. Number two, what that has also meaning that now if I use this bunch of code to set up this infrastructure, now if I want to repeat the same process, I don't need to start all over again with those same bunch of code. I'm going to repeat the same process. It will spin up all the whole servers, I spin up all the entire infrastructure I want at a go. Right. So that's what infrastructure as code does. And it's made it quite easy. Very, 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 very easy to be able to set up your infrastructure. Now, moving forward, then another one has been able to, help to introduce has been what you call containerization. Docker and containerization technologies revolutionized application packaging and deployment. Containers provided a consistent environment for applications, making them easily portable across different domains. I will explain this very, very fast. Now, part of the milestones of DevOps is, like I said, is containerization, which is what? The ability, a technology that allows you to be able to package your application and deploy them, seamlessly. Right. A technology that does what? That has helped you to package your application and deploy them seamlessly without having to, without making it quite portable. Now, there's an example I used to give sometimes when I try to talk about Docker, and the example is very simple. If I put a pool of water here and I put I put a jar of soap inside that water, if the water is not much, do you know that that jar of soap will get stuck inside that water because it cannot move much, right? It gets stuck. But if I pick up that same jar of soap, if I get 2 small containers, split that soap into pieces and put it in those little containers and put those containers inside the water, it will move. It will move. Now, so what we're saying is that Docker has helped, or containerization has helped to be able to package this same application that we've been deploying before, that is always very heavy, that are quite difficult, has made it quite portable, very easy to be able to deploy. So that is what containerization is, packaging your application and making them ready for deployment in a more easy, quite portable, and lightweight. That is what containerization has done. So, and containerization also, microservices is also, revolves around containerization, which is also the concept of breaking down your applications as well. For instance, now let me quickly give an example. A lot of us use some of the e-commerce websites. If you're in Nigeria, I'm sure you're familiar with things like Jumia. Now, Jumia is an e-commerce website, right? Now, if you go to an e-commerce website, you will see that there are several sections in an e-commerce website, right? You see that there's a catalog section. The catalog gives you a breakdown of all the products that it's available on the e-commerce website. Now there's a catalog section. If you are done with, maybe let's say you choose what you want. If you want to place an order, I'm sure you go to a different section to do that, to place an order. If you want to make payments, somewhere else you click to be able to direct you to where you're going to make payments, right? So now, same thing with services as well. Now, what microservice has done in the recent is that now all those sections have been broken down into sprints. They have been broken down into sprints on themselves. So each of those sections is a standalone, because microservice is more like a breaking down of a component, right, of your application into standalone components, right? So your what's it called? Your catalog section is a standalone component. Your payment section is a standalone component on its own. Right? Now, what that does is that makes the application able to work seamlessly, which is part of what containerization is saying. Microservices being able to have your application broken down to individual components where they can run on their own. So that's what containerization is doing. So I have to write that here. Let me be fast. Entertain questions. Now, DevSecOps, recognizing the importance of security in the DevOps pipeline. DevSecOps integrated security practices into the development and deployment process. Security checks and measures became an integral part of the pipeline. Now, this is just saying that now we've been deploying application, maybe automating our deployment of application through pipelines, right? So, and then there will always be need for us to be able to factor in security into all of this. Now, when you don't factor in securities, you make your pipeline vulnerable to all kinds of attack, and then also equally making your application vulnerable as well to all kinds of attacks. So DevSecOps, which is also a milestone in DevOps, right, understood that there has to be, because why? You're using your pipeline to be able to deploy that application. You're using that pipeline to automate the same application deployment, right? So but there has to be a need to do what? To be able to infuse security into that same pipeline so that the pipeline is not, vulnerable to attack, right? Which will automatically ensure that your application also becomes vulnerable to attack. So that's the concept of DevSecOps. Now, the best practices in modern DevOps: build your code, plan, test, release, deploy, operate, monitor. Then let me talk about automation. Now, automation talks about automating repetitive tasks from code integration and testing to infrastructure provisioning and deployment. So, automation, when you hear the word automation is just what a system that allows you to do repetitive tasks, without it being done manually. Right, that's the concept of automation. Being able to do your task repetitively without having to manually be tampering with them all the time. Right. So now, time will not allow me to now explain the process of automation. What's it called? Automating deployment. Automating deployment. Time will not allow me to explain that because it's a long process. But what I'm saying in essence is that what automation does is that, okay, let me quickly give an example. Now, there was a particular time that we had a slight challenge. For instance, now, if you go on your browser, I'm sure you have typed, there are some websites you try to access, and rather than you getting the page, the page of the website, you get something like this site that you are going to is not secure. I'm sure almost all of us must have experienced that. You get something like this site you are going to is not what? It's not secure. So two things: you're either going to continue or you're going to go back. Right. So there might be just some little write-up like, okay, if you continue, however, you might be prone to some kind of attacks or data leaks. That happens when maybe your website is not using a secure protocol, which is what you call your HTTPS. If it's not using a secure protocol, which is called your HTTPS, now that can happen. Right. Now that your secure protocol is what there's something called SSL certificate. Now, our SSL certificate is what you generate, right? That allows for your protocol, that's your domain, to be secure, right? So once it's secure, what it means is that when you type, for instance, you type let me say you type bbc.com. Now, you are a client that is trying to access BBC's website, right? You are establishing a communication, right, with BBC website, because you need that information. Now, there is something called data in transit, right? As you are doing that thing, you are trying to access the BBC website, right? You are making, let me not say get request. You are trying to access it. You are trying to access it. Now, at that point, if that protocol is not secure, what it means is that your own
Hello, can anyone hear me?
Yeah, I
Yes,
can hear
ma'am.
you.
Okay, I think we lost James Chukwu. Maybe his network or something. Hello, James Chukwu, can you hear me?
Yes, I can hear you.
Hello,
Can you
James
see my
Chukwu.
screen now? Yes, I can hear you. I can hear you. Can you
Yes,
see my screen now? Okay, let me quickly round up. I'm
yes.
almost done. Sorry, almost done. All right. So yeah, I was talking about automation. So and I was just saying that now automation, time will not allow me to explain all of this again. So automation is just purely having to do what? Having to get a process, right? That all your repetitive task is being done, right? Without having you to do them manually. So then collaboration, I talked about collaboration before, collaboration between the development and operation team to ensure that faster delivery of software lifecycle. Then continuous integration and deployment, implement CI/CD pipelines to deliver changes quickly and reliable to production. Then monitoring and feedback, continuously monitor applications and infrastructure to gather insights and feedback for improvement. I'm sure you know when your application is running, anything can actually happen. Now, if there's no system to be able to monitor your applications on a regular basis, if anything goes wrong with the application, you may not know. And the customers are definitely not going to be happy with you, and you definitely lose customers. So that's the reason why. Now imagine you are having a whole infrastructure that is running, and you're possibly, for instance, now, if let me just say this, for some of us that lives in Nigeria, right, or West Africa, that you are used to, you may have written an exam called WAEC, you may have written an exam called JAMB. I'm sure maybe many years ago when they started WAEC, where you could check your results online. I'm sure you may have had cases whereby you try to check your result and something, you are realizing that you cannot even access their website. What is happening? Maybe you could see something like server has crashed. Server has crashed. Do you know why the server crashed? The reason why the server crashed was because why? The server experienced so many loads, so many users, so many people try to use the website at the same time. And the server does not have the capacity to be able to. So if you have a system that monitors your infrastructure every time, you're almost not going to have that kind of issue. Because why? If for instance, if your infrastructure is experiencing an excessive load, for instance, you have some of an alerting system that alerts you that your system is experiencing an excessive load, then you can do what? You can be that. And then discussion and infrastructure for scalability and resilience, ensuring what? High availability. High availability is just you having your 0.9% all the time. And the scalability is the ability to be able to scale your resources, your computing resources up and down, depending on your load. And resilience is being able to do what? Is your application being able to withstand any form of
Hello, James Chukwu, we can't hear you if you are speaking. Hello, can anyone hear me?
Yes, yes, I can hear you. I can hear you now.
Can you hear him?
We can't hear him. We can't hear him.
So I guess something is wrong with his network.